Hello everyone. In this tutorial we're going to be covering text macros. There are two types of text macros. There's the type that we've been seeing over here in the introduction code for beginners, and then there's the type that are called modules. Now the first type of text macro we're going to be going over is the general text macro, which is we can see right here. Now this type of text macro is run using what's called a preprocessor directive. And what a preprocessor directive is a piece of code that only runs when the map saves. It does not run in-game whatsoever. A preprocessor directive always starts with the / exclamation mark here, and the lines are always grayed out, like so. So let's start by creating a new trigger and converting it to custom text. To begin with, we'll start with the / exclamation mark to make a preprocessor directive line. From here, text macro is a lot like a function. Instead of function, we have the text macro block, and then the end text macro, and then we have the name. For example, first text macro. Now you'll notice that I'm capitalizing it here because a text macro is what is called a constant. And constants with naming conventions are always capitalized. So for text macros, always capitalize them. When you want spaces between the words, you use underscores. Now I said they're a lot like functions because they have this optional takes keyword. And over here we can pass in the arguments we want to take. For example, arg1 or something like that. Now these arguments, you'll notice they don't have any types here. They do have the comma separated list like normal, but no types. And this is because text macro arguments are always strings. If we look back at lesson 3 to this text macro when we're running it, we're passing in a string here. And you'll also notice that again the takes keyword is completely optional. We don't need it there. We can delete it and it will still work. Go ahead and save that. It worked. Now to run this text macro, code can run it from either above or below. Text macro positioning doesn't matter. You can put them wherever you want, and text macros are also always global. You can't make a private text macro. So if we had a function up here, function boo, this function could actually run the text macro, even though the text macro is below it. And it ran. Now, if we look at the code here for running a text macro, we'll notice that it looks like a lot like a function. I can just change this to call and it looks like a plain old function call. The difference is, instead of the call keyword, the text macro keyword is used. And this is again a preprocessor directive, so the / exclamation mark is used. And it should actually be run text macro. So if we wanted to make this text macro take an argument, we can do takes arg1. Now we have to pass an argument up here just like regular functions. We can try saving that. Invalid number of arguments. So we pass in something like boo. Notice that that's a string. Now we can save it. Now text macros, what they do is copy and paste all the code within them to where they're being run. So we could do something like call print hi, and then when we save it, this code right here will be pasted right where the text macro is being run. I'm going to put a syntax there just to show. So we do a. Now look, there's the print hi, right in between these text macro comments. And there's the syntax there. Text macros can't run other text macros. So if we had another text macro here called second text macro, this first text macro couldn't run it, and the second text macro couldn't run the first. We can do try run first text macro, and we can see what happens. So I'm going to save it really fast. Run text macro inside text macro is not allowed. So you cannot run text macros inside of other macros. Now with vjass, you actually can. So if we look over here at vjass, this does in fact allow you to run text macros and text macros. But vjass is unstable. It doesn't work with some JAS code. And it's also not accepted online. So using vjass isn't really acceptable. So you just need to deal with not being able to run macros and macros. So let's go ahead and delete this. Now what about using this argument right here? Could it perhaps be just like a regular variable, arg1? No, it actually isn't. If we tried to save this, undeclared variable arg1. When you want to use text macro arguments, you have to surround them with $signs, like so. Now this still won't work because this print statement expects a string, and the only thing that's being passed in is boo, right there. So if we want to pass in a string, we use the escape character, which is a backslash, and then we do double quote, escape, backslash, and double quote. What the escape character does here, this backslash, is it stops special characters from doing what they normally do. For example, the double quote normally opens and closes a string, so here it's just transforming it into a regular character. For regular characters, it makes them do special things. For example, \n creates a new line. So the backslash is a special character, and in fact if you want a backslash character, you do \\. So it actually makes the backslash character just into a regular character. So let's go ahead and try passing in the boo here, this boo string, and save it. And now if we go ahead and put a syntax error there, there's the boo, call print boo. And now let's go ahead and move this out and see the text displayed in the actions over here. So run text macro boo in actions, test map, and there it is, there's the boo. So text macros are pretty handy, but they look a bit ugly because of this / exclamation mark, run text macro, etc., and they can't run other text macros. The other type of macro is what is called a module. These can only be used in structs, and they are not really preprocessor directives. They are, but they're like high-level ones. For one, they do not require the / exclamation mark. Instead, they just have a regular block. And so it's a module. That means it uses a module block. They cannot take arguments. So all that goes in here is a name, like name. And because they can be placed in structs, they cannot have structs placed into them. With a regular text macro, you can put whatever code you want into there, but with a module, you can't put structs inside of modules. You can't put scopes inside of modules either, because scopes can't go into structs. Libraries can't go into structs. But otherwise, you can put whatever sort of code you want. You obviously can't do functions, because it's a struct code, so it needs to be a method. And also the code within a module can be private. So if I did something like private method hi, takes nothing, returns nothing, end method, this hi method would only be seen within this module. If I were to put it inside of a struct, this module here, the struct would not see this method. And structs, or rather modules, can also have on-init methods just like structs. So this on-init method would automatically run for this module for every struct that's instantiated into. So that's pretty useful. Now the other great thing about modules is, just like text macros, they can be implemented from everywhere, anywhere. With the regular or vectoriant JAS helper, you could have private modules. So you could have, for example, a scope down here, scope hi, and scope, private module, oh my gosh, and module. However, with the Cohator JAS helper, he broke private modules. So the private keyword does not do anything with modules anymore. It does not mess the name up at all. And modules can run other modules. And how you run a module is use the implement keyword. So implement oh my gosh. And if we were to save that, it throws a syntax error about this that I forgot to delete. Let's try it again. And it works. If I were to do something like a syntax error in here, it still works. Oh, I know why. Because a module is a macro, so we need to make a struct first to have the code actually go into the map. So what we're going to do is implement name here, this module right here, and this module implements this module down here, and we should see that syntax error pop up. Oh, there we go. Actually, private modules do work, apparently. So the parsing does not actually go over this until it's pasted into a struct. Vexorian Jazz Helper did go over this stuff, but I guess the Cohater one doesn't until it's actually pasted in, so that's pretty cool, I guess, because that allows you to do some pretty interesting things, actually. For example, you could have scope, boo, and scope, private module, oh my gosh, and module, and then you could have struct tester in here. So let's have a private struct, actually. And you can go again. And now you can do something like, for this one you could do method cheese takes nothing, returns nothing, and method. And for this one you could do method O takes nothing, returns nothing, and method. And now when you implement it, it does not work properly. So, however, you could do this. And now this one will work and the second one won't. Or rather, both will work. And this is the module that's implemented. And if we do A here, there's the cheese. And there's the cheese again. So I guess the parsing isn't the greatest for the Jazz Helper. It's a little misleading compared to what it used to be. But it still works properly, sort of. It doesn't throw a syntax error here when it should, but it does look for only the module that's within the same area. So you can have private modules and whatever, but you can't use modules for like special settings or something like that. However, you can do something cool like this. Or let's keep it out, actually. So you could do a globals block. Private constant integer test equal 5. And then another globals block. And now, let's try a private static method on init takes nothing, returns nothing, and method. Let's get rid of this, and we can do call print I2S test. And notice this constant keyword. I haven't used it before, but a constant is just a variable that can never change. It can only be read. And notice it's capitalized because it's a constant. Oh, I forgot to delete that now, didn't I? Here we go. Perhaps I should move it into here. So now it's a static constant. And I'll change this one to 1. And now it works. There we go. So 2 different constants for the module. And this should display 5 and then 1. Let's go ahead and save again and test. And there it is, 5 and 1. So you can use constants like that to have special settings for your modules. You could even have custom code in here, like private method display takes nothing, returns nothing, end method, and we're going to do, oh, let's make that static actually. Call display. Let's repeat it over here. And let's make this one display 1 and this one display 2. Oh, display 2. Now it should display 1 and then display 2. And right display 1, display 2. So you can do a lot of fun things with modules. But a struct can only implement a given module one time. And if a module is implemented within that module only gets implemented that one time. So if I try to implement name again, it's not going to throw an error because it can only be implemented once. That makes them a little bit limited, but they're still pretty okay. There's one other interesting part about modules and structs and whatnot, but we'll save that for a later time.